Hey kids, welcome to another math video. This is again just to help you out because it's from lesson 14 in module 5 and it's homework, and these problems are just so super involved, very long, complicated, and so I want to help you guys out if you're struggling at home. Let's just jump right in. Also, I have to say, the previous video that I made for lesson 13, I'm using the strategy that my students prefer, which is to make improper fractions instead of using the distributive property, which, if you notice, is actually the objective of this lesson. Or of the previous lesson, it's to use the distributive property. And so we're using real world information that would actually work. And when it comes to a test, it really doesn't matter which strategy you use. You just have to be good at it. So I may go back and forth. I do try to put in the distributive property when I think it's helpful, but sometimes I will just use the improper fraction method and regular multiplication and long division because that's what my students are getting good at. So anyway, I might go back and forth. So here we go. Mr. Albano wants to paint menus on the wall of his cafe in chalkboard paint. The gray area below shows where the rectangular menus will be. Each menu will measure 6 feet wide and 7.5 feet tall. Nothing to do here other than look at the illustration. You can label it if you want, doing the 6 foot here and the 7.5 right here, 7 1/2 right there for this side. So how many square feet of menu space will Mr. Albano have? Well, we're not just talking about one menu, we're talking about 4. So when you use your area equals length times width to find the area of the menu space, we're going to also have to consider that it's 4 of them. So we'll take right here, jump right in, the 7.5 times 6 feet. But for each one, we then have to take that total amount area and multiply the whole thing by 4. So really easy to show you the distributive method on this one because, again, if you take it apart, you end up with a 7 times 6 problem, okay? And half of 6, which is a really easy thing once you see that it's half of 6. What's half of 6? Well, it's 3. 6 is made up of 2 parts, it's 3. So multiply this here, get your 42, and then half of 6, well, it's 3, but I'll show you math-wise. This is going to be cross-canceling 1 and 3. 1 times 3 is 3, 1 times 1 is 1, so you get your 3. 42 plus 3 is 45. So now we've solved everything in parentheses, and I can move on and multiply by 4 now because I will then have all 4 menus. Okay, so 45 times 4. I have so many students. I did it in my head, and then they make a mistake, and I'm like, please don't do it. Just help yourself out and put it on paper. 5 times 4 is 20. Carry the 2. That way, if you make a mental mistake, calculation error or something, you can go back and find it. This is 16 plus 2 is 18. Sometimes I go back and I'll have made a mistake, and I'm like, what? Where did it go wrong? It's very frustrating. But anyhow, it helps you if you have all the work in front of you. So how many square feet of menu space will Mr. Albano have? Here's our final answer. What's your unit? Go check it. It's feet. What's your label or exponent? It's squared. 180 feet squared of menu space. And you can also write that. Okay, moving right along. What is the area of wall space that is not covered by chalkboard paint? I recommend that you circle and underline important things. So if you look back up here at the dimensions, we've got a 25 by 13 2/3, and that's going to be the whole wall. So we have 25 times 13 2/3, and that's the whole wall. And we're going to have to figure that out first before we do anything else. That's why I put the parentheses there. But when we do figure it out, we have to have another step, which is to take away the menu space. So we're going to take away the 180 because that's how many feet of gray area or menu that is not going to be painted or whatever with the wall space. So we got wall space and we have menu space. So we need to find the difference. So let's solve this one. And this one, I'll show you again one more time because it's real simple when we only have like 2 parts of one. Take it apart. So it's 25 times 13. That's step 1. Then step 2 is to also multiply 25 times the 2/3. Remember, each number like this is a whole number over 1 because 25 divided by 1 is 25. So mathematically I can get that. It doesn't necessarily make it easier, or sometimes it'll take up more space if you do it this way. I think that's why my students really prefer this other method. Maybe I can do that on this side. 25 times 13, still have to set it up. It's double-digit multiplication. 5 times 3, 15. 6 and 1 is 7. Hold the spot with a 0. Then 5 and 2. 5, 12, 3. 325 plus what? Well, I can't simplify here, so I would have 50 divided by 3. If I have 50 divided by 3, you might think, oh, I have to set that up in long division because I don't know how many 3's go in 50. It's past 10 times 3, which is 30. So 3 goes into 5 one time. Use your long division strategy. Subtracting it 2, quick check, it's less than 3, so proceed. 20 divided by 3, 6. 6 times 3 is 18. Look, we get 2 again. Okay, that's going to kind of go on forever like that. So we're going to call this done. 16 and 2/3, and then 325. So now I have my whole numbers that I can add. And I like to carry over. If I've never been a super big fan of having carrying over on horizontal math, so watch where I put things. Sometimes students will say, wait, where'd you get that? So 6 and 5 are 11. Now this is the ones place, so I'm going to carry that over to the tens place, okay? 6 and 5 are 11, ones place, tens place. Now here's the tens place that I'm adding now. 2 and 1 is 3 plus 1 is 4. I don't have a hundreds here, I just have one here. So I have 341. And I've already added the wholes. Now we can't forget our fraction, 341 and 2/3. Okay, now we did this part. Take it up over here, and 341 and 2/3 minus 180. There's nothing to subtract here, so this is good. It makes it very easy. We just bring it right down. Okay. And for this one, there's no regrouping necessary. 1 minus 0 is 1, but there is regrouping necessary here. You cannot take 8 from 4. So take 1, give 10, if you can remember that. And then we have 14 minus 8, 6. 2 minus 1 is 1, and that leaves you with a 161 and 2/3 feet squared that is not covered in chalk paint. Okay, and then if you were going to use the 13 and 2/3 as an improper fraction, 13 times 3 is 39, 40, 41, 41/3, and then you would have the 25 times 41/3, so it's 25 times 41, and then you kind of proceed there. So anyway, it would take a little extra time and effort, and I don't think I have anything quick I can show you. So if you prefer to solve it that way, good luck. Work it out until you get 161 and 2/3. Okay, moving right along. Oh, yes, this one. We love these because we had a great discussion about squares, and 2 triangles make a square because when you put them together, it's like a puzzle. And so Mr. Albano wants to put tiles in the shape of a dinosaur at the front entrance. He will need to cut some tiles in half to make the figure. If each square tile, that means 1, is 4 1/4 inches on each side, and a square, the properties that make it a square is that it has equal amounts, okay, so the 2 sides, length and width, are exactly the same. What is the total area of the dinosaur? So you have to know how many full squares there are. So if you want to label them on the dinosaur, counting like this is really helpful. Okay, so now we have all of the full squares, but you have to, for every 2, I recommend just circling them, okay, in pairs as best you can. Notice that this one here has this little hiding one here and this one over here. Okay, so let's see, make sure I got them all. I feel like I didn't count right a couple of years ago and I got off a little bit. So if we have 12, 13, 14, 15, 16, 17, so that's going to be 17 tiles. And we're going to find the 4 1/4 times 4 1/4 for each one. That's using our formula area equals length times width, length and width, but we're going to multiply that by 17 because we need to get the total amount of tiles. So let's proceed. Easiest way, I don't know. I know the kids are going to want to do it this way. I'm going to do improper fractions here. 4 times 4 is 16 plus 1 is 17. I'll kind of give you guys a break. And then it's the same thing here. And so instead of having it all dragged out, this will be a lot sort of neater looking. 7 times 7, 49. 8, 9, 10, 11, 7, 1, 9, 8, and 2. Why did I leave that blank? Because it's a 0. Sometimes I just do that. 289 over 16. And now we have a division problem. I can't fit 2 16s in it. It would be 32, so I'm going to go with 1 and subtract. And then if this is roughly 20, it's obviously not, but if I was counting by 20, which is I wish I had that number, 20 would be 5 of them for 100, 6 of them for 120, and I have less, so I'm going to either do 6 or 7, so let's try a 7. 7 times 6, 54, I'm sorry, what am I thinking? 7 times 6 is 42. And 11, and that gets us, oh, so close, no, 9, 8, 7, yeah, just a hair to, look at this. I rarely get the opportunity to show you what happens here, but here's a great mistake. It's not really a mistake, it's just part of dividing. So let's say you put up a 7 here, and you get 17 here. This is where the compare step is very, very important. 17 is bigger than 16. You can't have that there. That means you have to bump this one up. I have to have 8 here because I can fit another group of 16 in there. So you just take off what you calculated and start over. 6 times 8 is 48. Carry the 4. 8 times 1 is 8 plus 4 is 12. And look at how close we are now. We're only 1 away, which is the difference that we had before. So it was very, very close. Anyway, 18 and 1/16 is what we have here, and we carried down that, so I've got the total that vertically I would bring down 18 and 1/16, and that's for the 4 1/4 times 4 1/4. Now I need to multiply that by 17. And here, probably no easy way to go about it. 18 times, I'm going to separate this one out because 18 times 17 is going to be easier than doing this times this plus this and then multiplying it by 17 again. So let's do 18 times 17. I'm going to use the distributive property here. Plus 1/16 times 17 over 1. I'm just going to lay it out like that. We still have to solve 18 times 17, so write it out or use your X. There's our 8 times 7, 56, and 12, and then we've got 8 and 1. Add 10, 3, so I've got 306. Plus, look at this. 1 times 17 is 17. 16 times 1 is 16, so you end up with 17 16ths. That's really easy. That's like 1 and 1/16. So if I'm adding 306 plus 1 and 1/16, I get 307 and 1/16. And that is, what's our unit? Inches. squared for the dinosaur. For the dino nugget. Ha. Okay, so there you go. That's your final answer for the front page. Huzzah! Okay, back side. It doesn't get any easier. Excuse me, getting my water. Okay, keep going. All right, A+ Glass is making windows for a new house that is being built. The box shows the list of sizes they must make. 15 windows at this size, 7 windows at that size. How many square feet of glass will they need? Oh boy. Well, we're going to have to find the large windows. You can't really say large because these are sort of a 4x3. These are a 2x6. This is large. This is larger than this. So they're all pretty big, but we've got a set of 15 and 7. Organize your work. First, we have to take our 4 3/4 times 3 3/5. And when we get that, we have to multiply it by 15. Okay, so that's going to be for all of these. Then, I'll probably end up erasing that, but we'll have to do the 2 4/5 times 6 1/2. That's the other size window, times 7. So if you write everything down and set it up, and again, you can always just pause the video and see if you can do it by yourself without me doing it for you. I highly recommend it at this point in the year. You need to know what you're doing. Okay, I'm just going to go out on a limb here and solve it the way my students want to, not using the distributive property. 16, 17, 18, 19 fourths times 15, 18 fifths. Don't worry about this just yet. I can cross cancel here. These are both even, so I could take, it's not a multiple of 4, so I can just take 2, divide by 2 and get 2. Take 2 and divide and get 9. So now I have at least something a little smaller. I'll end up with tenths on the bottom, and I have 19 times 9 on the top. 9 times 9 is 81, and then 9 plus 8 is 17. 171 tenths. So that's not too bad. If you would like to set it up with your standard algorithm over here. Oh, this is probably going to happen like 12 times today where the lights go out because it's such a long lesson. 171 divided by 10, so you get your 110 in there. Multiply, subtract, compare, bring down, divide 71 by 10 to get 7, multiply, subtract, and get your remainder. Okay, so that is 17, I'll put it below, and 1/10. And see how it kind of works out nice because it's a little bit neater. I'll show you briefly on my other page. Sometimes I have this, open and handy, and sorry for the blurry. But this is like the calculation that you would do with the distributive property. So taking the 4 times 3, and then the 4 times 3/5, and then the 3/4 times 3, and then the 3/4 times 3/5. This is what I mean by sometimes it just takes up a lot of space, and you still have to do a lot of work. So doing it with the improper fraction suddenly looks like, hey, that's not so bad. And this is the way your parents like to do it, because they'll say, you can just make an improper fraction and it works just fine. And they are right. So there you go. So 17 and 1/10, and that is feet squared for the 15 windows. Oh, or is it? No, that's just step 1. My bad. See, I got distracted with showing you guys the other stuff. So I need to take the 17 and 1/10 and multiply it by 15. That's our second step. So let's do 17 times 15, step 1. Okay, plus 1/10 times 15. Now put 15 in a fraction over 1 so that you can do cross-canceling if possible. I can, and I will. Let me solve the 17 times 15 first. And 7 times 5 is 35. Carry the 3. 5 and 3 is 8. 7 here, 1 here. Add them up. 15, 2, 55. And then cross cancel here using a 5. So 10 divided by 5 is 2. 15 divided by 5 is 3. And then we get 3 over 2, which is 1.5. And you get 256 and a half. Double check. Yes, yes. Got it right. Woohoo! It's always a celebration. I'm not even kidding. It's a celebration that I got it right. Okay. 256.5 feet squared. And that is for the 15 windows. Let's just note that. And I'm going to give myself a little bit more room here so I can take care of this, and then we can combine them. All right, let's do improper fractions again and see how that turns out. 5 times 10 and then 14 fifths times 12 13 halves. Oh, look, we can simplify again with the even numbers. 2 and 14 crisscross. This is going to be a 1 and this will be a 7. Now I have the 13 times 7, and I really wanted to, sorry, I got distracted. It's like squirrel. Don't forget to multiply this time. So I have 7 times 13 over 5. So 13 times 7, but I want to do it in my head. Nah, just write it out. 7 times 3 is 21. Carry that. Then we have 7 plus 2, 9. So we have a 91 over 5. And then write this out too. Long division. 9 divided by 5 is 1. Multiply, subtract, compare, bring down, divide this by this, divide 41 by 5. Sorry, I shouldn't say this. I should point it out. Get 8. 8 times 5 is 40. Subtract and get 1. There's your leftover amount. So 91 fifths is really 18 and 1 fifth. But look, there's more. Now we're going to multiply this by 7. And so we have, let's use, I'm going to use the distributive property this time. 18 times 7 for step 1 plus 1/5 times 7. Just put that over 1. This will be easier. I'll show you in a sec. 18 times 7, got our 56. I feel like we just did this on another problem, like literally a minute ago. 7 plus 5 is 12, so we have 126 plus 7 fifths. And 7 fifths is so easy. That right there is 1 and 2 fifths. Okay, so I have 126 plus 1 and 2 fifths, which is 127 and 2 fifths feet squared for the 7 windows. So now we have our 2 parts. How many square feet of glass will they need altogether? We're going to add them up right here. Take your 256.5. Ooh, here's what I'm going to do. I'm not going to have to do it twice. I'm going to do it once. I'm going to take my half, and I will have to add to the 2 fifths. What will be my common denominator? It will be 10. I'm going to convert right now. So instead of putting 1/2, I'm going to make this 5/10. That's equivalent. I just want to be able to not have a huge mess. Plus 127. And now I'm going to convert this to tenths. So everything is times 2. That's your scale factor. 4/10. Now we can add everything together. You can add your fractions first, kind of see what happens with that. You'll get 9/10. That's not too bad. No improper fraction. Then place value position by place value position. 6 and 7 is 13. Go over to the tens place. 5, 6, 7, 8. Hundreds place, 3. 383 and 9/10, and we got the answer right again. So we should like skip and dance and sing because this is our final answer. Square feet of glass. Feet squared of glass. And that's our total. Yay. Star. Happy face. Smiley. Okay, and then we only have one more, and this one's super weird. And we didn't actually... I don't always get to stuff in class, so we didn't get to this one in class today, but maybe you will get to it with your teachers. Maybe you are a teacher and you didn't get to it. Do not feel bad. More water for me. Okay. Anyway, we're going to do it now. Mr. Johnson needs to buy seed for his backyard lawn. If the lawn measures 40 4/5 feet by 50 7/8 feet, how many square feet of seed will he need to cover the entire area? It's an area question, length times width. So for this one, it's kind of fun to use the distributive property. I'll show you. Don't be afraid of it, please. 40 4/5 by 50 7/8. Remember, if you have 4 pieces, you'll have 4 expressions. The first one is 40 by 50. That looks like it's shaping up to be an easy problem. Okay, and the second one is 40 by 7/8, or multiplied by the second part of the fraction. The next piece is to take the 4/5 and multiply by the first number, and then with the plus, 4/5 times the last fraction. Notice that we always have these fractions at the end if you've got a fraction and a fraction. But check it out. It works out to be not too bad here. Okay, first of all, I can use mental math with 4 and 5 for 20, and then a 0 here and a 0 here. So you should have a 2,000. Then you can cross cancel here with 8 and 40, and whenever you can get a 1 on the bottom, boy, that makes your life easy, because now it's 5 times 7 on the top and 1 on the bottom. That makes a total of 35. Nice whole number there. Look what happens here. Same thing. Cross cancel. Look at that. We have 1s on the bottom. 4 times 10. It doesn't get any easier than that. And look here. I can cross cancel with my 4 and my 8. Divide both by 4 and get 1 and 2. Now I have 7 over 10. 1 times 7 for 7. 5 times 2 for 10. So after all that, it looks crazy, and aren't you glad we didn't use improper fractions here? That would have been insane, like such huge numbers, and you could do it so easily like this. So when you put your whole numbers together, 40 and 35 makes 75. I have nothing to add it to here, so it's 2075 and 7/10 feet squared. And that's all there is to it. So see, the distributive property is sometimes totally amazing. Now, second part of this, kind of atypical, but let's just read it and you'll see. 1 bag of seed will cover 500 square feet if he sets his seed spreader to its highest setting, and 300 square feet if he sets the spreader to its lowest setting. How many bags of seed will he need if he uses the highest setting? So these problems are connected because I need to know how many square feet I'm trying to cover, and then this is telling you how many square feet I can get per bag. So you've got 2 little problems here. I feel like I have work that's showing through here. You have 2 little problems. You're going to have a 500 as your divisor and 300 as your divisor to get the 2 different bag or the settings for the spreader. So let's just do the first one with a 500, and we're going to use our answer from here. But I'm going to turn it into a decimal. Can I do that? Yes, I can. What is 7/10 as a decimal? It's 0.7. 7/10. 7 in the tenths place. See? Cool, right? So if I don't have any decimals out here, I'm going to put my decimal up. Decimal up right now. Can you fit 500 into 207? No, you cannot. So there's no digit here, nothing here, nothing here, but I will have a digit here. And when you think about how to divide these big numbers, it's really just looking at the first 2 digits. So I would be thinking about maybe 4, because 4 times 5 is 20. So you put your 4 up here, and then you have your 2 zeros, and 4 times 5 is 20. And I will have far less than 500, so I'm okay with 75 left over. Okay. Now you go ahead and bring down the 7, and then it's as if you're dividing 757 tenths by 500. But I could only fit 1 of the 500s tenths in there. And you do your subtraction, and you get your 257 tenths as your leftovers. If you would like, you could keep going. However, so like I could put a 0 and we could keep going, but it just becomes kind of an activity in uselessness. Why? Because once you get past a whole bag, so like what are we finding? What does 4.15 represent? So it represents bags. How many bags of seed? So how do you buy a 4.15 bag? Well, you don't. You go into Home Depot and you say, I'm going to need 5 bags. Because if you said, hi, Mr. Home Depot person, or hello, Miss Home Depot lady, whoever's working in the garden section, I need some seed and can I get 4.15 bags? And they would say, ha ha ha, no. You can get 5 bags or 4 bags, but we're not going to rip it open for you. So bump up the whole, and you would have to get 5 bags. And that's for the highest setting. Okay, now same approach, whoa, there's a hole. Okay, same approach for the lowest setting, but instead of using 500, we're going to use 300 because it's not letting as much seed out. Lowest setting 2075.7. There you go. Same dividend, but different divisor. Okay, so it's only going to cover 300 square feet. Oh, that's probably because it's letting out more seed. So anyway, irrelevant. Sorry, I get distracted. 300 will not fit into 207 at all, so we still have to go over here for our first number in the quotient. But you have to think about how many 3s could I fit into. Again, same thing, roughly 20. If I go to 7 3s, I would end up with 2100, and that would be not appropriate. So I'm going to go back to the 6, have my 2 zeros for 6 times 0 and 0, and then 6 times 3 is 18. Do your subtraction, and you get 275. Close to this, but still less. Okay? Bring down your 7, and now we're into the fractional units again. And look at the first 2 digits. I want to get as close to this without going over, which would give me a 900, and then 9 times 3, there's your 27. Subtracting, get 57 tenths, and I could keep going, but it's irrelevant because 6.9 represents the bags, and you can't tell the Home Depot employees, can I get 6.9 bags of grass seed? Because they will say, no, you may not. So you're going to bump up to 7. And click subscribe and come back again so I can help you with more math. So 7 bags for the lowest setting. And we will see you on the next video. And I hope you guys have a great day. And if you're in my class, I'll see you tomorrow.